Good day po everyone. I am Nabil Berceo from BSECE3E. I'm going to discuss about convolution. In this video presentation, I'm going to discuss about two: continuous time convolution and discrete time convolution. So let's proceed first to continuous time convolution. In continuous time convolution, convolution is used to combine two signals to produce a third signal. The continuous time convolution operation is defined as, so this is the operation of continuous time convolution wherein x of t is the input signal. It represents a continuous function of time. H of D is the impulse response. It is also called the kernel or filter. It describes how the system responds to an impulse input at different time points. Y of D is the output signal, which results from convolving X of T with H of T. T is the time variable for the output signal, Y of T. And the integration is performed over all time from negative infinity to positive infinity. So let's discuss the convolution process. The first one is sliding. To compute y of t at any specific time, the convolution operation slides the impulse response across the time axis, aligning it with each point in time. The next process is multiplication. At each time step, the product of the input signal x of t and the impulse response h of t is calculated. The next one is integration. These products are integrated over all time from negative infinity to positive infinity to compute the value of y of t at the specific time. And the last one is repeating. This process is repeated for all values of t, resulting in the entire output signal y of t. So the convolution operation essentially shows how the input signal x of t is modified or filtered by the impulse response h of t. It's fundamental tool for understanding the response of linear time invariant systems in signal processing. Also, convolution can be used for tasks such as filtering, feature extraction, and analyzing the influence of a system's characteristics on the input signal. Now, let's proceed with the next one, discrete time convolution. In the, in the discrete time domain, the convolution operation is defined for discrete sequences rather than continuous function. The formula for discrete time convolution is as follows. So this is the formula of the continuous time convolution, wherein x of n represents the input discrete time signal. It is often a sequence of values at discrete time instances. H of n is the impulse response or filter in the discrete time domain. Y of n is the resulting discrete time signal. It is also referred to as the convolution of x of n and h of n. And n is the discrete time index. So in discrete time convolution, the process for discrete time convolution is similar to continuous time convolution, but it is adapted for discrete sequences. It involves sliding the impulse response across the discrete time axis, multiplying and accumulating the products to compute the values of the output signal at different time indices. Discrete time convolution is commonly used in digital signal processing, image processing, and various other applications where signals are sampled or quantized in discrete time steps. So overall, Convolution is a fundamental operation in signal processing, and it plays a crucial role in various applications where signals are analyzed and processed to extract information, filter noise, or understand how systems affect input signals. That's all for this video presentation about convolution. Thank you.